Here's a check for understanding on page 681. So we're going to do a chi-square on this thing. So look at a bag of peanut M&Ms. So the company says that there's 23% blue and orange, 15% each green and yellow, 12% each of red and brown. Okay. And so this kid Joey bought a bag and poured them all out, counted them all up. And here we go. He's got, this is his count for this bag. So we're going to do a chi-square test. Now, number one says, state the appropriate hypotheses for testing the company's claim about the color distribution and the peanut M&Ms. So I'll do that. So here's our null hypothesis, and that is that the probabilities for the candies is what the Mars company says it is. So we just kind of list them. Probability of blue, right, 23%. Probability of orange is 23%. Green is 15%. Yellow is 15%. We just list them. Probability of red is 12%. Probability of brown, shoot, I should probably do something different for that. I guess like that, so we don't use the same thing. So anyway, we just list them. Now let's do the alternative hypothesis. And here it is. Now we're not going to say that the whole bag is wrong. We're just going to say at least one of the colors is incorrect. So one or more of the colors doesn't follow these proportions. That's what we're trying to say. So let's do the test. So the second part of this problem is we want to get the expected counts. Well, there was 46 in the bag. So we take the probabilities and multiply them all by 46. That should be what our expected count is. So there's all the expected values. Now what do they say in the problem? Let's see. So 12 blue, 7 orange, 12 blue, 7 orange, 13 green, 4 yellow, 13 green, 4 yellow, 8 red, and only 2 brown. Okay, so we can kind of compare these two. They don't look too bad. The only one that looks kind of weird, maybe this one. This one had, what, almost twice as many, right? This one has twice as many in the other direction. Anyway, so what do we do with this mess? Okay, so what do? We take the observed value minus, so let's just say, whoops, hold on a second. Let's say the observed value, which is for blue, 12 minus 10.58, and we square that, and we divide it by 10.58. Got the 8 up there. Then we add that to the next one, which is 7 minus 10.58. It's the observed minus the expected, squared divided by the expected. And we do that for all of them. I'm going to keep going, like this one down here. I'll do one more. So what is it? It's 13 minus 6.9. And you square it and divide it by 6.9. And we do that for every color. And then we add them all together. That's our chi-squared. And if you do that, you should get the number is 11.37. 11.37 is our chi-square. Chi-square. 11.37. There you go. Now I'm going to continue on page 684 for the other check your understanding. Now it says, confirm that the expected counts are large enough to use chi-square distribution. So all we need to check is the fact that the expected counts are all 5 or more. And yes, they're all 5 or more, so we're good on that. And that's kind of like our normal condition, so large sample size. Okay, that was number one. Number two, sketch a graph of what it should look like. Well, our chi-square is going to look something like this. So, and it's always skewed to the right, but where's the hump, right? Where's the middle of this thing? And it's always 2 less than the number of categories you have. So in this case, we have 6 categories, which means the middle would be right about at 4. And this would be 3, 2, 1, 0, 5, 6, 7, 8, 9, 10, 11, 12, that kind of thing, okay? So if we were out here at our value is what, 11.7, so it's something like this. And we would be saying, well, what's the area of that graph there? I think it was 11.7. 11.7. Let me double check. Oh, it's 11.37. Whoops. 11.37 is what our graph would look like. How about well, I just like using the calculator. I don't like using the table. Maybe I should show you the table tomorrow. But anyway, let's use the calculator. So it's a little different than normal CDF. I'm going to go to chi-square CDF, and the lower is going to be my 11.37. And the upper is going to be, how about 100? And the degrees of freedom, that is 1 less than the number of categories we have. We have 6 different colors, so we're going to make it a 5 for the degrees of freedom. And let's check it out. What is it? So 0.04451. So our p-value equals 0.0445. So in this case, if we had an alpha level of 0.05, or if they just don't say it, we use 0.05, this is lower than that, which means we would reject the null hypothesis and say that one of those color categories is pretty whack. I'm assuming it's the one, which is the one that was weird. I think it was the red ones. We expected, 6.9, but there was actually 13 of them, so that probably threw the whole thing off. Anyway, there you go.